Hello, welcome to our channel again. Suraj here, and today I'm going to generally solve a differential equation, which is the question on the screen. As you can see that this particular question is from the Riley Hobson Benz Mathematical Physics book. If we are want to learn something deep mathematics to learn higher advanced physics, then the Riley Hobson book is really a very good book for you. So I picked pick up this particular question from that particular book. So this is generally a nice question and I will show you that how to approach this question by the method of exact and inexact differentials. Maybe you are familiar with it. And if you're not familiar with these types of differential equations, then I have made a video on the ordinary differential equations, on the exact and inexact differential equations. I will put down the link in the description box. You can watch those videos first. Then you will understand that how I'm going to solve this particular differential equation. So this differential equation contains two parts. First of all, you have to find out the value of alpha and here beta, because as you can see that here alpha and beta, we have to find out the values. And after finding the values of alpha and beta, we have to solve this particular differential equation for our here function, which is the differential fxy 0. What you have to do is that we have to just put down the differential 0 and we have to solve this particular differential equation. In this video, I'm going to show that how you can find out any of the given constant if it's given in any of the differential equations like here, alpha and beta. And after knowing this, it's quite simple to find out the answer solution to this particular differential equation. So let's start the question for solving the values of alpha and beta. So if you remember what is the exact and the inexact differential equations, then there are certain type of the, you can say that relations between the variables. If you remember that how we can write out this particular setup, then this particular differential equation is similar to this, which is a x y dx and plus b x y dy is equals to 0. So this is the differential equation form that we are encountering in this particular question. So you can see that here our A is this particular quantity here in the bracket and B is this particular quantity. So there is a very important relationship between these two particular A and B, which is del A divided by del Y is equals to del B divided by del X. It means it is a relation that we have to differentiate this particular A, this particular A, which is 1 by x squared plus 2 alpha by y with respect to the y, and here B, which is x, y raised to the power beta plus 1 with respect to the x, and these two quantities are equal. And if these are equal, the differential equation is an exact differential equation. So in this particular question, it is given that this is an exact differential equation. So by using this relation, we can find out the value of alpha and beta very easily. There are other methods also, but this is the simplest method I have ever encountered to solve this particular question. There are also different types of other relationship between A and B, but if I try to do this, then it's look like very complex. So this is quite good to do. So now we only have to differentiate, and remember this is a partial derivative. So if you have watched my lectures on the partial differentiation, then this partial derivatives encounters when we have to deal with more than one function, not only x, not only y, both x and y, or whatever this is, combinations of the functions. So let's differentiate. So here, del divided by del y of a. So a is 1 divided by x squared plus 2 plus, if you differentiate 1 over y with respect to the y, it's equals to the negative of alpha divided by y square. Okay, let's put a big bracket. can be written as is equals to, we have to differentiate now b with respect to the x. So del upon del x of x y, sorry, x y beta plus 1. So now here, if we have to do the partial differentiation, so we are doing with respect to the y, and here is x. So treat like constant, this will become 0. And if I differentiate it, I have written here the differentiation of this particular quantity, alpha by y, so which is negative of alpha divided by y square. What I have done is that I have written it previously, that what should be the derivative of alpha by y, and it's negative of alpha by y square, and this particular thing is equals to, if you remember, if we treat here del by del x of x y beta treats constant and x will 1, this is equals to y beta, and of course 1 is a constant, so the differentiation of 1 will be 0. Now here it equals to negative of alpha y negative of 2 is equals to y beta. It means, if you see it very carefully, you can find out the value of alpha and beta both. So first of all, if you equate the bases and power, you find out that the value of beta is equals to negative of 2 and alpha should be equal to negative of 1. Because if you put alpha as negative of 1, this negative and negative become positive. And if you put here as y minus 2, and if you put beta as minus 2, this is exactly equals to the same. It means finally we have figured out the value of what is beta and alpha. Quite simple. Yes, this is very simple question. It's look like that, oh my God, this is a very big question, but actually it's simple. Now we find out the value of here. We have find out the value of alpha and beta. Now we have to solve this differential equation. So this is your homework problem, to solve the differential equation, because we just find out the value of this particular alpha and beta, and you have to just plug down the values into this equation, and you put dfxy as 0 and integrate it, and you can solve this differential equation. So this is today's video on the very simple question to the differential equation. And maybe the solution to this differential equation process can be quite complex, but it's actually an easy question. So hope you find this video useful, and you have to solve this particular differential equation and give the answers in the comment box.